In order to train your sentiment model, you're going to need a set of testing data and training data. I had an entire data set of sentiment analysis data, which has one column or feature, which is the comment or review. And then the other column was, which is going to be our target field, was whether it was a negative or positive review. So I needed that data in order to be able to train my model. I was able to get some of that information online. I actually downloaded 1 million records of Yelp reviews, and I'm using that to train. So one really important thing that needs to be done beforehand, though, is they need to be separated into these subcategories. So you notice that I've created folders within the main folders. The main folders, of course, are the training folder, which is very important, and testing, just as important. Within them, I will have a subfolder for every classification. So in this case, we only have 2 classifications, either negative or positive. So I have 2 folders. Within each one of these folders are text files. And it's an individual text file, much like if you're training a vision model, you'll want to put an individual image inside of the folder. And each one of these is a individual text, and all it says is a text rating, for example. And this one was determined to be negative, for example. So as is the case with any kind of training, I have 1 million records, so I put about 800,000 of them inside of the training. So they're broken up between positive and negative. And then I took 200,000 of those and put it inside testing, because the general rule of thumb is you should have about 20% of your entire data set should be used for testing. Now, I mixed them all up, so they're not coming sort of in sequential order. It doesn't really matter too much with sentiment, but sometimes it might. So let's say you sort of shuffle the deck and then take 20% of it and use it for testing data. Same thing applies here. You need to have the same syntax for your subfolders, because that's how your classifications are going to be determined. Then you open up Xcode. And the reason I say to open up Xcode is because you're going to have an application inside of Xcode, which ships with Xcode, called a developer tool. And those developer tools can be found by going under, there we go, the Xcode menu and choose CreateML. Create a new document, and then you want to pick the template. So these are all the different templates. If we drill down into text, you'll see that under text classification, it has the reference here to sentiment. And that's what we're going to do. We're going to create a text classification model. I'll hit next. I'm going to name this. And this information just sort of gets saved within the project. See what the project file looks like. So the project file appears there on screen. So now what I need to do is I need to map the training data that you see here and the testing data to the folders that I just showed you. Those are also on the desktop. So let's first look for training data. And all I need to do is point to this training folder. It will recognize within the folder that there's multiple classifications. So after this gets a chance to load, we will be able to see how many classifications it identified. Once your training data loads inside of the CreateML tool, you'll notice that you get 2 pieces of information, mostly for confirmation purposes. At first, you'll see one of them, 450,000 items. That means that I fed 450,000 individual text documents to for the purposes of training the model to CreateML to do so. And that's why it took so long. So normally it takes just a few seconds to be able to load items, but I am deliberately trying to do this with a massive data set. Now, the other part, 2 classes, is really a confirmation, because what that is that when I created the data that I was sending over to the model, I created a training folder, and inside the training folder, I created 2 subfolders. That's how you determine what your 2 classes are going to be. So in this case, the 2 classes are, if we click over to view, you'll notice that one of the classes is negative and one of them is positive. And I have nearly identical sets of items or training data. I tried to make them identical, but I was off by a few there. So you can see that I have almost equal sets of negative and equal sets of positive, and I have a ton of data here too. So we should get a pretty good model out of this. And the way that we determine how good the model is going to be is based on precision. And we'll get some of that after we load some testing data. So skipping over validation, because we have that set to automatic, I now need to select the testing data. So we go back to our original source, And you'll see here that I have another folder with the same two classes. And this is important. My training data set, which has negative and positive, should match the testing data set. And just as a refresher, I have about 20% of the original training data represented in the testing data sets. So we should see those numbers prove out. So I'm just going to choose the testing folder, and I will load that testing data folder, and then we'll get that same confirmation back once those items are ready. And now we have our testing data loaded. We see the same two classes, and in this case, 110,000 or so items. If I click on view, you'll see what that breakdown is. A pretty even 50-50 breakdown between the same two classes, positive and negative. So that, of course, comes from the data sets, the subsets of data that I fed over to the model. So if I go back into model sources, and here we are on settings. Now all I have to do in order to train it, now that I have my training data and testing data, is simply hit the play button here that says start training. When your training has completed, you'll see a status on the bottom here. You see mine says completed training, and that will mean that I can get into some of these other tabs. So let's take a look at the training tab. This gives me just a visual feedback on the training accuracy and validation accuracy throughout the process. I'm looking for high 90s, 98.7% training accuracy. Over 31 iterations is very satisfactory to me. So I will be very happy with this run. And then there's some other ways to determine this. You can see that I'm looking at the couple things here. First, I've got the training, and I can see that I have a precision of 99% on both positive and negative, and recall of 99%. In general, high numbers are better, and 100% is impossible to achieve. It would basically mean that you've, let's say, provided all of the same reviews for positive, all the same reviews for negative, and then you test using the exact same reviews, for example. So 99% is outstanding, and I'm not surprised with the amount of data that we fed to this model. And then now what it does is it goes through the auto training. So you usually get a little bit lower numbers here. So my precision is still very, very good in the 90s. And then finally, when we take a separate data set, so this is more like what you'll end up getting, in production, for example, you'll see that 110,000 items or so, and I'm still getting in the low 90% precision. So I'm very happy with these results. So next, on this next tab, at least in the case of doing some of these text-based models, it allows you to preview. So I'm going to just put some text in here. This is actually a review from my listings review site. So I simply paste it in here, and I'm getting back the same type of data that I will get in the JSON data that's returned from the function inside FileMaker. So you see that I get 99% confidence on positive. So usually you get a combination of all the different classes and the confidence percentage. So what we're looking at here is there's only two classes, so the 100% value will be split between the two of them. You'll be able to see this in FileMaker, but the idea here is that 99% with 0 negative is outstanding. And really probably what it means is it's like 99.000 something, and then it's 0.00001 or something negative. Regardless, this is a good example of the data, an actual data that I'm going to be using, and the model looks like it is ready to go. So when you get over to the Output tab, you can see some information about the model and some of the information I put in when I first started it. Now what I want to do is output this. So what I can do is just hit Get, and then I will pick the location where I want to save this. I'll just save it to the desktop. And now you see that we've got a second file. So first you'll notice that the first file that was created is called .mlproj. That's the project file. That's this file that I'm working with. So think of that as the authoring environment. And the file that gets produced outside of the authoring environment is called a .ml model. This is the file, specifically a .ml model file, that is the file that you can put inside of a FileMaker container field, and it will run that model. So that we went through all this process of training and testing and producing a model so that we could put it inside of a container field in FileMaker. So let's move over to FileMaker to see what we do with these .ml model files.